Welcome back to Three Inquisitive Kids. If this is your first time here, my name is Karen, one of the recorders on this channel. And in this lesson, we're going to be beginning Unit or Chapter 8 of our 7th grade math course, where we're going to be talking about angles and geometry, things like that. So in this first lesson, we're going to be looking at vertical, complementary, and supplementary angles. Chapter 8: Exploring the definitions and features of vertical, complementary, and supplementary angles. Before we go into this lesson, I highly recommend you to, pause videos when you need to, rewind when you need to listen to something again. Really pause at the problems so you can get the exercise that you need yourself. And also, I really recommend you bringing a notebook with you and a pen or a pencil so you can take notes about the key points in these lessons. So yeah, right now go grab a piece of paper and a pen, and yeah, let's get started. This is part 1 in our first lesson, the positional relationships between lines. So part 2 will be coming up. And if you're interested in that, you can always subscribe, click the notification bell, and then you will be notified when we upload that lesson. But as you can see, we also have 1, 2, 3, 4, 5, 6, so 6 other lessons coming up as well. Exploring the conditions of parallel lines, properties of parallel lines, and drawing angles with rulers. So yeah, for that lesson, you should probably also bring a protractor, a ruler, things like that. Anyways, for this lesson, the two learning goals of today is to understand the concept of vertical angles, supplementary angles, and complementary angles, and to grasp the properties of vertical angles, supplementary angles, and complementary angles, able to apply these properties to solve problems. Now here's your introduction. Observe these following pictures and think about the positional relationships between straight lines. So, for example, in this room right here, in this apartment, what lines can you identify and what are the positional relationships between them? Well, I see that there's some windows here. They look parallel, perpendicular. Yeah. So those are some observations that you can find. Here is a highway. You'll see that there are two lines. You can think of the highways as two lines, and then they're intersecting. And we also see a picture of a staircase where multiple lines on the rails right here are, so there's one that's intersecting them, but there's also vertical ones that are parallel to each other. And finally, for this last picture, we see a bridge. And on this bridge, there are multiple diagonal lines that are that are intersecting to each other and are also parallel. Roads, horses, mountains, and bridges can be seen everywhere in life. In the masterpieces of natural and artificial creations, there are countless intersecting and parallel lines that can be observed. On the same plane, the positional relationship between straight lines can be intersecting or parallel. So you can say intersecting lines or parallel lines. If two lines intersect at one point, we call them intersecting lines. Two straight lines that do not intersect are called parallel lines. Now I want to make one thing clear. Would this and this, for example, be parallel lines? True, they don't. In this, when we're drawing it, they're not intersecting. But remember, lines mean it's not a line segment, but a line, meaning that it goes on both sides forever. So that means that if you do extend this is just a portion that we've drawn here, but really this line is extending forever onto both sides, and eventually they do cross. So a parallel line is even more specific, actually. It's two lines that even if you extend them, they will never ever intersect. So that's something to think about right there. Vertical angles. Exploration 1. As shown, lines AB and CD, so we have AB and CD, that are intersecting at point O. And now, what positional relationship do you observe between angles 1 and 2. And there's also 3 and 4. So you'll see that angle 2 is highlighted in red here, and angle 1 is highlighted in green. The two things that we can observe is that they have shared vertices, which is this point right here, and you can also think of their angle sides as extensions of each other. For example, let me write down A here. AO and BO are the sides of two separate angles, but AB is one line. So this is what we mean when we say the angle sides are extensions of each other. Lines A, B, and CD intersect at point O. Angles 1 and 2 shares vertex O, and their angle sides are extensions of each other. Angles like this are called vertical angles. So whenever you have two intersecting lines, the angles that they create on either side of the intersection point will be vertical angles. Exploration 2. What is the size relationship between angle 1 and angle 2? So here we have the same figure, but what is their size relationship? Well, their size relationship is that angle 1 is equal to angle 2. Because we know that vertical angles are congruent. This is the feature of vertical angles. Here's our conclusion. Vertical angles, as shown, A, B, and CD intersect at point O. Angles 1 and 3 have shared vertex O, and their angle sides are extensions from each other. Angles 1 and 3 will be vertical angles. Angles 2 and 4 are also vertical angles. So this is the two things that make a vertical angle a vertical angle. So this is something that you should be taking note of. And also a cue for whenever you need to take notes. When it says knowledge key point or conclusion, those are usually good, or if they have like a graph that summarizes kind of what we've learned at the end of the lesson as well. Like those are all good places for you to stop, pause the video, and write down something you've learned. Property of vertical angles. Vertical angles, not vertical angels, vertical angles are congruent. Let's do a problem. In which of the following figures are angle 1 and angle 2 vertical angles? That's right, the correct answer is D. Because here, does it meet all of the requirements? Well, 1 and 2 right here, their angle sides are extensions of each other, and they do share one vertex. That's why D is the correct answer. A vertical angle is formed by two intersecting straight lines, and only when two straight lines intersect can a vertical angle be formed. As shown, lines A, B, C, D, and E, F all intersect at O. Angle 1 has a measure of 40 degrees. Angle BOC has a measure of 110 degrees. So now find the measure of angle 2. Okay, so this is it has two steps to this. But once you really think about what it's saying, then you'll understand. Here's a solution. Because we know angle 1 is equal to 40 degrees, and we know that angle BOC is 110 degrees, that's given in the problem. Also, I want you to observe how this solution is set up. We first write S colon because it's a solution, and then each of the steps in the reasonings are listed out with commas and parentheses to show how the explanation of that step. Therefore, BOF is the same as BOC minus angle 1. That means it's equal to 70 degrees. But since we know that angle 2 and BOF are vertical angles, we know that angle 2 has a measure of 70 degrees. So we have angle BOF is equal to angle 2 because we know vertical angles are congruent, and therefore angle 2 is equal to 70 degrees. And we get that from equivalent substitution. Now we're going to talk about complementary and supplementary angles. Here we have angles 4 and 3. If we move angle 4 over, right now it's a bit overlapping, but let's ignore that. We see that they add up to 180 degrees. Now, if the sum of two angles add up to 180 degrees, which is a straight angle, these two angles are called supplementary angles. Angle 3 and angle 4 are supplementary angles, or you can say angle 3 is supplementary to angle 4. Now, same if we have angles 2 and 1. Pretend that this point right here is overlapping on this vertex. Now, angles 1 and 2 add up to 90 degrees, which is a right angle. Then these two angles are complementary angles. Angles 1 and 2 are complementary angles. Now let's do some practice. Here we have an angle, and then I want you to fill out the corresponding complementary and supplementary angles to that angle. So this would be 85, 175, and you can pause the video if you want to fill it out first by yourself. 58, 148, and their corresponding values are all right here. And remember, this is a minute, and a minute is just 1/60th of a degree. Now, if this were x degrees, where x is less than 90, then its complementary angle would be 90 degrees minus x degrees and 180 degrees minus x degrees for its supplementary angle. We can conclude that the supplementary of an acute angle is blank greater than its complementary angle. What relationships do you observe between these pairs of numbers? Well, the supplementary angle is always 90 degrees greater than the complementary angle. Now we're going to look at the properties that supplementary and complementary angles have. As shown in figure 1, when playing pool, which is a game, choose a direction to hit the red ball with the white ball so that the red ball will go directly into the bag after bouncing, right here. At this time, angle 1 is equal to angle 2, ON and DC intersect at O, and angle DON is equal to angle CON, which is equal to 90 degrees. So we can simplify this into figure 2. Discuss and answer the following questions. Now you might have someone that you can discuss with, or you can just think in your head. In figure 2, there are 3 questions. Which angles are supplementary and complementary? What is the relationship between angle 3 and angle 4? Why? And what is the relationship between angle AOC and angle BOD? Well, because angle 1 is equal to angle 2, we know that they both add up to 180 degrees. They're supplementary angles, as you can see in this figure. Therefore, angle AOC is equal to angle BOD. Supplementary angles of equivalent angles stay the same. So if you have two separate angles that are congruent or have the same measure, and you're finding the complementary angle for both of them, that is the same complementary angle. So in other words, we're saying one angle can only have one complementary angle and one supplementary angle. And this is figure 2. And because we know angle 1 is equal to angle 2, we can add up these complementary angles and we have 90 degrees. Therefore, angle 3 is equal to angle 4. Complementary angles of the equivalent angles stay the same. In other words, one angle can only have one complementary angle. Example 3. As shown, angle AOB is within angle AOC. Angle BOC is equal to 90 degrees. OM and ON are the bisectors. So bisector is a line or a ray that splits an angle in half of angles AOB and AOC. AOB and COM are supplementary angles. Find BON. Well, let's do this together. We know that AOB and COM are supplementary. Therefore, AOB plus COM is equal to 180 degrees. That's from the definition of supplementary angles, which we also know that angle AOB plus angle BOM plus angle COB is equal to 180 degrees. Because, as you can see here, we can split COM into BOM and COB. And we also know that COB is equal to 90 degrees. That's given in the problem. Therefore, angle AOB plus angle BOM is equal to 90 degrees. And because OM is the bisector of angle AOB, we know that angle BOM is 1/2 of angle AOB and that angle AOB plus 1/2 of angle AOB, so of itself, is equal to 90 degrees. Therefore, angle AOB is equal to 60 degrees. And also, because of that, we know angle AOC is equal to angle BOC plus angle AOB, which is equal to 150 degrees. So that's one step. And then the next step, and I also want to be paying attention to how I'm saying because and therefore. This symbol with the 2 dots on top symbolizes because, and this symbol, which it has 2 points on the bottom, it means therefore. So because ON bisects AOC, we know angle AON is 1/2 of angle AOC. Therefore, it is equal to 75 degrees. We know that angle BON is equal to the difference between AON and AOB. So angle BON would be equal to 15 degrees. Class summary. So we learned about complementary angles, supplementary angles, and vertical angles. So the property of vertical angles are that they're congruent. And now let's look at complementary and supplementary angles. The quantitative relationship between angles for complementary angles is that one angle plus another angle is equal to 90 degrees. And that its properties are complementary angles of equal angles are the same. So here it would be written out as one angle plus another angle is equal to 180 degrees, and this is its visual model. Supplementary angles of equal angles are the same. Again, today we understood the concepts of vertical angles, supplementary angles, and complementary angles. We also grasped the properties of vertical angles, supplementary angles, and complementary angles, and we're able to apply these properties in order to solve geometrical problems. So, thank you for watching Through Inquisitive Kids. If you enjoyed this video or found it helpful, please click the like button down below. We really appreciate it. And we'll see you next time.